Very good morning, student. I, Dr. Kumar Sonu, and today we will be discussing a numerical problem on assembly line longest candidate rule. So let me read out the problem statement. A new small electrical appliance is to be assembled on a production flow line. The total job of assembling the product has been divided into minimum rational work elements. The industrial engineering department has developed time standard based on previous similar jobs. This information is given in the table below. In the right hand column are the immediate procedures for each element as determined by the precedency requirements. Assuming a cycle time of 1 minute, find out the balance delay. To solve this numerical, first we will be plotting the element number, that is right from 1 to 12. It's not here, it's 12. Okay, and in this column first we will write element number. In the second column we will be writing the process time, and in the third column we will be plotting the precedency by. Okay, so here the minimum the process time for each element is given here, and 10th element the process time is 0.38, and for 11th element the process time is 0.5, and for 12th element the process time is 0.12. Similarly, the preceding of the element is so element number 1 there is no preceding, so element number 1 is blank, that is nil. For element number 2 again the preceding is nil. For element number 3 the preceding is 1. For element number 4 the preceding is for element number 3, for element number 4 the preceding is 1 to 2. For element number 5 the preceding is 2. For element number 6 the preceding is 3. For element number 7 the preceding is again 3. For element number 8 the preceding is 3 and 4. For element number, this was element number 8. Yeah, for element number 9 the preceding is 6, 7, 8, and for element number 10 the preceding is 5 and 8. For element number 11 the preceding is 9 and 10, and for element number 12 the preceding is 11. So this table has been formed. Now we will be finding total work time. So we will be calculating total work time TW. So the total work time is nothing but the total processing time. That means TW we can write it as number of element. That is, if I say number of element, if I represent it by small e, so TW is nothing but small e into summation of the process time, TP, process time. So we will just simply, meaning to say that we will just simply add all the process time here. So if I add all this process time, what I will get? The total, if I add this process time, I will get what? TW as 4 minutes. What we will get? We will get as 4 minutes, right? So once we have calculated the TW, we know TC. TC is what? Cycle cycle time is given in the numerical, and TC is given as how much? 1 minute, right? TC is given as 1 minute in the question paper, it has been given. Now, to decide the number of workstation, if the number of workstation is represented as small n, so small n workstation will be nothing but TW divided by TC. TW divided by TC. So total work time is how much? Total work time is 4 minutes and TC is given as 1 minute. So n is workstation, that is workstation is nothing but 4. Minimum workstation that you have to keep for this 12 element is 4. First constraint. So constraint. So first constraint is that the minimum workstation should be 4. Okay. Second constraint is cycle time is 1 minute. Okay, with these two constraints we will allocate the 12 work piece, the 12 work element into minimum of 4 work station. Okay. Suppose we have given minimum 4 only. Workstation 1, workstation 2, workstation 3, workstation 4. Okay, we have given 4 workstations. Now in 4 workstations, from the question it is said that the element 1, can you see the element 1 here? Element 1 is having no precedency time. It can be started initially only, right? So initially it can be started because we have no precedency. We don't have precedency here. So element 1 will be starting here. So element 1 is first we will allocate element 1. Okay, element 1 timing is how much? Element 1 timing is 0.2 minute, right? Element 1 timing is 0.2 minute. Element 2 timing is how much? 0.4. Okay, now element 3 timing is how much? 0.7. So if I add this 0.7, 0.4, 0.2, how much it is getting? 1.3 minute. This means this is exceeding 1 minute. This is exceeding 1 minute. That 1 minute is the cycle time. So we cannot put element third in the first workstation. We will not put the element third in this workstation because when we are adding 0.7, it's exceeding 1 minute. Okay, it's exceeding 1 minute, so we will not put box element 3 here. Now let's move to the 4. Can we put 4 here? Yes, because 1 and 2 will be here. After that we can put 4. So 4 element is how much? 4th element is 0.1 minute. Okay. Now let's come to the 5th element. Can we put 5th element here? Fifth element is after completion of point 3, right? After completion of fifth element is after completion of point 2. So what is the timing it's taking? Point 3, right? So if we add it, how much it comes? 1 minute. That means cycle time is 1 minute. We can put cycle time equals to the total processing time at each workstation. So this constraint is over here. Now we have to put element 1, element 2, element 4 and element 5 in first workstation. First workstation. So timing is how much? 1 minute. These are minute, okay? Minute, minute and minute. Okay. Now let's come to the second workstation. So in second workstation, the third element we have not put, right? The third element I have not put, so third element will be placed here in workstation 2. So what is the third element? Third element timing is 0.7 minute. 0.7 minute is the third element time. Next, fourth is already allocated here. 5 is already allocated here. Now we will go to sixth one. Sixth one we can put because third element process has been done. After third element process we can put the sixth here. So sixth element timing is how much? 0.11 minute, right? Now we will go to the seventh one. Seventh we can put here. Seventh we can put here just proceeding time is how much? 0.32 minute, right? So if we add this, it's exceeding 1 minute. So we have to remove the seventh one. Seventh element. Seventh element will be put in the next workstation. Okay. So if we add it, how much we are getting here? 0.81 minute. Okay, so here in this workstation we will put 3 and 6. Now 1, 2, 3, 4, 5, 6 elements has been done. Next 6 is pending here. Now we will go to seventh one, right? Seventh one we can do because we have done the third one. So we will put 7 here. 7 equals to how much minute? 0.32 minute. Now 8 element 0.6. 0.6. 9. Can we put 9 also? Let's see. 9 if we put 9 is how much? 0.27. If we add, how much we get? How much we get? 1.19. Huh? 1.19. 9. No. 3 and 9, 9. So how much we are getting? 1.19. That means it's exceeding 1. So we will replace 9. We will replace 9 and we will put here how much? 2, 9. Right? 0.92 minute. So in this column we will put 7 and 8. Now once we have assigned 7, 8 workstation, now what we will do? We will go to 9th one, right? 9th one is preceded by 6, 7, 8. 6, 7, 8. The process 6, 7, 8 has been already completed. Now we can go for 9. So 9th will, after this 9th will come here. Okay. If I put 9 here, let's see. 9 is equals to how much minute? 0.27. 10 is how much? 0.38. 11 is how much? 0.5. I think it's exceeding, right? Yes, sir. It's exceeding. So 11 we will remove. Now what is the total here? Total how much minute comes? 6, 5. Okay. So 9 and 10. Last, see, in the numerical, the minimum number of workstations that we will put is 4, not less than that. Okay. Maximum we can put any number of workstations. So n is 4 here. When n is 4 here, that means in 4 workstation we are not able to complete the entire assembly process. So for that, to complete the entire assembly process, we have to increase the number of workstations. So let's increase one more. Let's see here. Now process 11 and 12 is left here, right? So 11 is preceded by 9 and 10. 9 and 10 element assembly has been done here. So we can write it here as 11. So what is the timing for 11? 0.5, and for 12 it's 0.12. If we add it, how much we get? 0.62 minute. This is also here 0.65 minute. All units are in minute. So to complete this entire work element, we need 5 workstation. 11 also and 12 also. So we will write here 12. So 5 workstations are required. 5 workstations are required to complete this assembly process. Okay. We can see the balance delay. Balance delay. So balance delay is given by n Tc minus Tw divided by n Tc. So what is n here? Small n is the number of workstation. So actually initially we found that workstation as n as Tw divided by Tc. This is the minimum number of workstation. But actually when we are putting minimum number of workstation, the two constraints that we were having is not fulfilled in 4 number of workstations. So we increased it to 1 more. So in 5 number of workstation, the entire work process element has been put up. So here n will be 5. Tc has been given already in the question paper, that is 1 minute. Tw we have calculated as 4 minutes. Okay, so the balance delay will be something as 5 into Tc. Tc is how much? Tc is 1 minute minus 4 divided by n is 5 into 1. So this comes as 1 divided by 5. So that means as 0.2. If we convert this into percentage, it will come as 20%. So balance delay is by 20%. Okay.